everyone. I am Shilpa Pathak, heading Civil Engineering Department of Parul Institute of Technology, and I welcome you all for this today's webinar. Title of this webinar is an overview of physical model studies. So, why we kept this topic? Because generally, in case of hydraulic structures, big structures are constructed, but before construction, we require some testing, some design analysis, and in laboratories, it is to be done on certain physical models. So it is very useful or one of the kind of best practices to keep our structure safe or to check our designs in a very proper manner. And for that, today I have invited Deepika Pradhan. She is working in GARI, that is Gujarat Engineering Research Institute at Baroda office, and she is a research engineer over there. She has already worked, she's having 8 years of experience in academics as a teacher, and she loves to teach students. Basically a teacher. She has worked under Water Resource Engineering and Management Institute as a temporary lecturer for 8 years, and then she joined a government job as a junior engineer and worked, and then taken the position as assistant engineer. She worked for 17 years under Sardar Sarovar Punarvaswat agencies, and since last 4 years she is with Gujarat Engineering Research Institute, working as a research engineer, preparing physical models for the upcoming government projects. They are dealing design analysis and testing things at the large campus which is located at Gotri in Baroda, and she is handling the entire unit. So it is my immense pleasure to invite Deepika madam for this webinar. I, on behalf of our university, I thank her for sparing her valuable time to conduct this webinar. So welcome, Deepika madam, and it is over to you. You can present your screen, and viewers, if you have any questions, you can WhatsApp your respective FRs, and they will send your questions to me. So at the end, we will have some question answer session. And if the situation permits, madam is there to help us for physical visit. So enjoy the session, students and viewers, and it is over to you, Deepika madam.
Thank you very much. Thank you, Shilpa ma'am, for introducing me. Now I would like to take over and starting the presentation. So good morning, everyone. I am just switching over to our presentation. So our today's topic is an overview of physical model study. This is already madam has explained you what is physical model study. So today I would like to discuss in detail what is physical model study. So first I would like to introduce my department. So this Narmada Hydraulic Division is the dealing department for physical model study. So at GARI, it is having its field hydraulic laboratory at Gotri campus, and it is spreaded over 140 acres of land, and it is working since 1971. At this campus, GARI is having its own basic infrastructure like tube wells as a source of water, pumping station, gated canal network, a well-equipped workshop, and library to carry out the hydraulic research study by physical hydraulic model technique. And since up till now, more than 150 models have been tested here, and various hydraulic parameters related to irrigation structures like dams, weirs, barrage, canal structures, bridges, river training works, etc. are studied on sectional 2D model and comprehensive 3D model by selecting suitably geometrically similar scale. We will go in detail what is 2D model, what is 3D model, and what is GSS scale, what is distorted scale. I will explain you later on. So this is just the introduction of my department, who is dealing with the physical model study work. Now we will start with the model. So what is model? Everyone might be knowing what is model. So model is a miniature scale version of prototype made with the rules of hydraulics. And what is prototype? The prototype is an actual size of structure which is constructed on site. So all of you might be knowing what is the difference between model and prototype. So whatever construction is going to be made on the site, first it is tested on our model. So that is model and prototype. Now what is model study? So model study is a complete study which offers great contribution in the field of engineering, medicine, art and rocketry. So what it gives? It gives complete information in advance by spending very little amount of amount compared to actual cost of the project. Then project completed by such information becomes defeat free and very economic and fruitful. Now we will see the benefits of the model study. So you will get the idea how important it is. First, we will see the objective. The main objective of physical model study is to ascertain the hydraulic parameters during planning, construction, and post-construction stages, and also to suggest remedial measures for its effective functioning. So, this is the main objective of the physical study, which is to ascertain the hydraulic parameters. So, we are ascertaining the hydraulic parameters during planning, construction and post-construction stages, and also to suggest remedial measures for its effective functioning. So physical models are useful during planning as well as during various stages of construction, and after post-construction also we can study on the physical model. Now these are some benefits of physical model study. So physical model study basically is one of the best tool to solve the complex flow phenomenon. When mathematical models and analytical methods are having limitations in simulating the complex flow conditions. See, all of you might be knowing, so there are certain number of tools. So physical model is one of the tool. Another model or another tools are mathematical models and analytical methods are also there. So in mathematical models at present, HACRAS, then MAI, these are the softwares which are worldwide used for solving this complex flow problem. But when it is difficult to simulate the complex flow conditions in this mathematical model, we are just preferring the physical model, where you can see with your eye all the results. So that's why physical model is more preferable than this mathematical model. Then physical models have been used worldwide for solving the complex flow problems. So which type of problems we can solve? The hydraulic problems of all hydraulic structures like dam spillways, barrages, weirs, bridges, canal structures, flood protection works, etc. So whatever I have written, all these type of problems we have solved at GARI since last so many years. So I have already narrated that this is working since 1971. So most of all the projects of Gujarat were first studied here and then it were implemented on the site. because government is going to spend lots of money for any project. So before spending that money, whatever is designed, whether it is proper or not, so that should be tested somewhere. So that is tested on the physical model, and then it is implemented. If it is okay, then only it is implemented. If there is any corrections are needed to be made, or means modifications are needed in the design, then that is modified. Again, it is tested on the physical model, and then it is implemented. So scale models are constructed and operated at specific as per specific need. So depending upon the specific need, we are planning the model. So the scale and all that thing also, the size of the model, that is based on the requirement. Now, physical models gives qualitative idea about flow pattern and hydraulic parameters like velocity, water level, scour effect on bed, etc. So at Gary, we are studying these hydraulic parameters like velocity, water level, scour effect, all these things we are studying on the scaled model, and that is given as a output for report in the report for next implementation. And many alternates can be tried to select the best alternate on the basis of performance on the physical model. See, I have already discussed that suppose a designer has designed something and there is some means it is not functioning well. So again, they have to redesign it, and the next alternate can be studied. So there are many alternates you can study on the physical model with a little amount. So you can study this all the alternates, and out of that, which is the best, that alternate you can choose, and that can be implemented on the site. Then performance of structure at different stages of construction and for the post construction stages can also be assessed. Here I would like to give the example of Sardar Sarovar Dam, which was started in 1961 and completed in 2017. So it took 56 years to complete the project. So at it, the construction was stage wise. So for 90 meter, like 120 meter, 110 meter. So at different stages, construction was carried out. So for all that stages, what is the effect? So suppose if you are going for height 90 meters, so what will be the submergence? What is the effect on the upstream? What is the effect on the downstream in the surrounding area? So all this was first studied on the physical model at Gary. So there were total 38 studies were carried out for Sardar Sarovar Dam. I will show you the pictures also afterwards, so you can get the idea. So 38 studies were carried out for Sardar Sarovar Dam up till now in the Gary. So at various stages of construction also you can use the physical model. Now we will see the application part. So what are the applications? So we are doing this for hydraulic structures. So first we will see the in dam structures how it is tested and studied. So for dam structures, they are tested for flood passing capacity. So whatever structure you are going to design, what is the capacity? Whatever you have designed, is it okay or not? So the flood passing capacity is tested over the model first. Then to check the design of energy dissipating arrangement. You have already studied this energy dissipating arrangement, hydraulic jump, that you might have studied whenever water is passing on the or barrage. So at that time, tremendous energy is there. So we have to dissipate on the downstream. So otherwise, what will happen? It will erode the bed of the river. So we have to first design the energy dissipation arrangement. So this is very crucial part. The design should be such that the jump should be within the this arrangement only. So that can be, that is checked. So here in 2D and 3D model we are checking it, but in 2D model we will discuss later on what is 2D and what is 3D model. So in 2D model this is tested. So precisely we are getting the result in the 2D model, and on that basis, this is finalized. Then upstream submergence. So whatever design means structure is designed in the river. So we are obstructing the river flow. So what will be the submergence? So whatever calculated that they are on the basis of your equations. But actually whatever design, whether this is okay or not. So on upstream submergence, so that spread of water on the upstream of the structure, that can be studied on the model. Then gate calibration. So gate calibration can also be done. So you can operate the gate. Suppose you have designed the gate that suppose this much discharge you want to pass through the gate. So 5 centimeter gate is to be open. So on this opening, how much discharge is passing? So whatever calculated, is it passing or not? So that can be tested on the model. Then bank erosion in the downstream side. So this can also be studied on the model. Then performance of tail channel. So on the downstream side, what is the performance of river? That is on the tail channel. So that can also be studied on the physical model. Now canal structures. So you might be knowing we are having a very long canal network on the Narmada project. So that all Narmada canal were tested in Gary. So for canal structures, we are studying for alignment. That is also important parameter. So alignment of the canal can be tested. Then discharge carrying capacity, that can be tested. Then performance of cross drainage work. You might have studied all these cross drainage works. The CD works means when canal is crossing the river. So whether sometimes canal is above the river, sometimes canal is below the river. So depending upon the site situation, CD works are given. So on the all these structures which are designed to cross the canal, so they are tested first and then it is implemented. Then performance of canal lining. You might have studied there are various types of canal lining. It may be brick lining, it may be CC lining. So what is the performance of particular lining material? So that is first tested on the physical model. Then performance of gates on canal. So you have already studied that head regulator, cross regulator. These are the type of gates which are there fixed on the canal network to operate the canal. So they are also tested first on the physical model. Now river behavior. See, for river behavior also studies are carried out. So effect of meandering route of river. So this is a very crucial part when river is meandering. So what is the effect on the surrounding due to meandering? So that is first studied on the model. Then river training work. Sometimes there is need of river to be trained. So after training the river, what will the effect? That is first studied on the model. Then adequacy of banks to pass the flood. So at the time of flood, what is the capacity of that bank to pass the flood? So that is tested over here. Sometimes bank protection works are also carried out. So that is needed to safeguard the city when river is passing to city or village. So at that time we are suggesting some bank protection works so that flood water cannot rush to the city or villages. So that bank protection works are also designed and that design is tested on the physical model and then it is implemented. Then effect of river crossing structures like bridges. See, what is the important thing in bridge? Whenever any bridge is constructed on river, so there are number of piers. So number of piers are there which are obstructing the flow of river. So at near the pier, what is happening? Due to obstruction, there is tremendous covering. So we should design the shape of pier in such a way that minimum covering will be there. So effect of so if you are designing number of shapes, so out of that which is to be selected. So that can means number of shapes can be tried on the model and then out of that which is the best that is suggested. So this is the applications of physical model. Now I would like to discuss what procedure we are adopting to take any project. So first, what is that? So receipt of letter from project authority to carry out model study with terms of reference. See, suppose any project is coming to Gary for model study. So what is the first step? The project authority is writing to us and they are giving the terms of reference. You might be knowing what is terms of reference. Means what is the purpose of that study and what outcome they want from the purpose, means the present study, so that they are giving to us. Then we are preparing the estimate as per model study SOR. So what is SOR? You might be knowing that is schedule of rate that we are preparing at Gary. So on that basis we are charging the amount. So then we are giving to this estimated amount to them. They are depositing the amount with, and we are also giving one checklist. So what type of data required for model study? This is the most important thing. Data, without proper data, we cannot reproduce the model. So that data is required. Then after depositing the amount, and receiving the data, we are first analyzing the data, and then we are deciding the problem, and we are on that basis we are deciding the scale and dependent size of the tray. So this is our procedure. So what type of data required? So you are a civil engineer and in first year in surveying also you have studied the topographical data, then hydraulic data, then structural data. These are the main type of data which are required to reproduce the model. So first data is survey data. So in which form we need? So survey data, first we need is index map showing the location of proper structure on river and nearby area. So proposed structure that is on the river, that index map is needed. Then latest grid map showing the RL at an interval of 30 meter. So for the entire river reach to be reproduced, that is also needed. So we are working on this grid map. All these models we are preparing in the square grid map with the interval of 30 meter by 30 meter. So we are working on this, that RL are transferred to our model RL, that is our PGR reading. So that is pointer gauge reading. We are using pointer gauge for this depth of water. Okay. So this is the important data which we need. Then latest contour map showing the contour at an interval of 1 meter for the entire river reach to be reproduced. The study area which is surveyed. So for to know the topography, we are requiring this contour map, because we are also reproducing the model in the river reach as well as on the banks also. So depending upon our requirement, we have to select the area, how much area is to be studied. Then latest cross sections of river at an interval of 5 meter. This is CS cross section at 5 meter along the center line and 30 meter across the river. So this is the requirement of survey data. Now to reproduce or to construct the structure on the model, we need the structural data. So whatever structure is to be designed, the detailed drawing of plans, elevations and sections of structure and suggested appurtenant works is needed. Then detailed drawings of proposed energy dissipating arrangements, including details of training walls. Because whenever you are constructing any structure, you have to guide the river flow. So on the upstream as well as on the downstream, so at some length you are proposing training wall. So water can be, whenever it is entering in the structure, at that time it is guided. The flow is guided. So detail of these training walls are also needed. Then detailed drawings of the proposed gates on the spillway, including position of the trunnion axis. See, all of you might be knowing. So in any dam structure, whatever flood water is to be passed, that is through spillway. So on spillway, we are having the gates. Either gates, maybe suppose barrage is there, then vertical gates are there, or suppose Ogi spillway is there, then radial gates are there. So for radial gates, we need this trunnion axis. So gate operation can be also tested. This is the hydraulic data. Why it is required? This is the main thing for any structure. So maximum discharge and corresponding high flood level observed at various important locations during last 10 years or whatever may be available for validating the model. See, when we are reproducing any model, so we have to test whether it is perfect or not. So how we can test this model? So we need some data from which we can validate it. So if we are having any breach, so on every breach we are measuring the water level. So if we are knowing that water level, so we are, when we are running the model, we are having various discharges. So we are running the model at 10% discharge, 25% discharge, 50%, 75%, and 100% discharge. So at various discharges, what is the water level? Because at every year flood is not 100%. We are designing the structure for 100% discharge, but every year the flood means rain is more or less. So depending upon the rain, the discharge is passing is varying. So we are running the model at 10%, 25%, 50%, 75%, and 100%. So at these various discharges, what is the corresponding water level, observed water level? So that we are taking from the project authority. And when once our reproduction is over, in virgin condition, before constructing the model on the before constructing the structure on the model, we are first running the model to validate it. So this data is required for validation of model. The actual observed gate discharge curve. This is most important data which is required for validation of model. Then the tailwater level. I have already explained here that for particular discharge, what is the tailwater level at particular RL. Suppose at 60 meter or 120 meter. So at that RL tailwater level, we are fixing on pointer gauge and that we are attaining. So if once we are attaining this tailwater level, then our model is okay. Otherwise, we have to do some rectification, or whether is there any discrepancy, then we have to solve the error. Then information about river morphology, like erosion of the bank during past flood, then change of erosion marked on the map showing the erosion patches, etc. So this is also required. So these are the data required for model study. Now, first I would like to discuss about 3D model. See, we are having two types of model we are running. So this is composite model, composite three-dimensional model, and another one is sectional 2D model. So first we will discuss the 3D model. So for 3D model, what is the procedure? First, select the proper scale of model based on the river regime to be studied, maximum discharge required, and space available for model study. So this is the base on which we are fixing our scale. So suppose 1 in 100, 1 in 70, 1 in 80, depending upon the study area, availability of land, we are fixing the scale. So scales are of two types: geometrically similar scale. So in geometrically similar scale, most of the time we are planning to select the GSS only, because we are getting better result in GSS scale. So geometrically similar scale means horizontal scale and vertical scale are similar. And sometimes suppose larger area is to be covered. In Barboot model, we have covered nearly 70 kilometers of area. from Shukla Tit to Bhadbut village, and on the downstream side up to sea 5 kilometers. So 70 kilometers of area where was needed to be covered. So in that we have gone for distorted model. So you can select the scale depending upon the requirement. So these are the two types of scale. Then two types of models are also there. Sometimes we need rigid bed model and sometimes we need mobile bed model. So river bed material, sometimes there is rocky strata is there in the river. Sometimes sandy strata is there. So in sandy strata, we are going for mobile bed. And suppose rocky strata is there. So then we have to go for this rigid bed. So first step is to select the model, then convert the actual topographical level to model scale and reproduce the river topography in model using pointer gauge. So this is the second step. Once we have finalized the tray size, then fixing the scale, we are converting the data. Whatever data we have collected, the first topographical data we are using. So that data is converted to our model scale and then we are starting the model. So after that, run the model for calibration and validation. So once topography is, I am showing the topography. So this is the topography. At present, we are having the gift city model of Gandhinagar. So these are, you can see these bars. So that are at 60 by 60 meter grid. This is our grid map. See, this grid is 30 by 30 meter grid map is there. This is Shahpur Bridge and here it is PDPU Bridge. So between these two bridges, at present work is going on for river front of Gandhinagar. So we are working on this at present. So this is grid map and this is the topography. From that grid map we are reproducing the topography. So once the topography is over, what is the next step? Run the model for calibration and validation. So I have already discussed that known discharge and water level which is taken in the hydraulic data that is implemented here and model is run for this calibration and validation. So once it is calibrated, then we can say that our topography and model is okay. Then next step is the reproduce the proposed structure like dam, barrage, weir, guide bund, etc. Whatever drawings they have given, on that basis, on this our scale, we are starting the construction of this structure. Once the structure is ready, our next step is to run the model at various discharge. I have already explained for various discharges, we are running the model and take the observations. So what type of observations we are taking? So water level. With the help of pointer gauge, we are taking the water level. Then velocity. We are having the current meter also. So with the help of current meter at various location, we are taking the velocity. Then scour. The scour of the bed is also tested once the model is run for 10% discharge. So in the on the next day, the water is receded. So after receding of water, we are measuring the scour. Sometimes some at some place there is siltation and some places scouring is there. So that pattern also we are giving through this model study. Then flow pattern that can be also studied how what is the behavior of flow after construction of the structure. Before construction we have tested in the validation and calibration. So at what is the behavior of river that before construction and what is the behavior of river after construction. Then location of hydraulic jump. See, this is also studied on the model. So whether it is on the energy dissipating arrangement or not, that is studied. Then adequacy of length of stealing basin. This is the part of adequacy of length of stealing basin mean it is part of energy dissipating arrangement. Your this hydraulic jump should be within this stealing basin only. Then next is height of training wall. Whatever training wall on the upstream and downstream is suggested, we are constructing here on the model, whether it is overtopping or not. whether it is sufficient or not. So that is checked on the model, and guidelines are also checked. Then the detailed report including observations, conclusions and limitations from model study are prepared and submitted. This is the procedure we are adopting. This is Lakroda Barrage on river Sabarmati. Before 2 years we have studied this. You can see the model. This is that red portion is your energy dissipating arrangement. This is Lakroda Barrage. So without gate this is constructed here. This is just one bridge is there just downstream of the structure. So it is the very problematic situation. So this Lakroda Barrage was tested after construction also. So post construction studies were also carried out on this Lakroda Barrage, and due to this high erosion on the downstream side, you can see the erosion also. See this grit is there, no? So that's showing the erosion. Whatever grit was there on the just end seal, after the end seal, that was washed away and came towards the bridge piers. So this was studied, and finally this steeling basin was extended. So they have given 30 meter, 40 meter. So 2-3 suggestions they have given. So all these steeling basin lengths were tested, and finally inclined bed was suggested, and that was finally carried out on the site. Now we will see the 2D model. So in this picture you can see the overall whole structure is covered. This river on the upstream side, this is downstream side. So on 3D model you will get the overall idea. Suppose if you want to study specific study, so what is the effect? Here you can see the overall effect. So suppose you want to see the study the energy dissipating arrangement is proper or not. So out of this whole area we are, suppose there are 50 gates. So out of that 50 gates we are selecting 2-3 gates in which are crucial. So that are tested on the 2D model. I am showing the picture. This is 2D model. So only two spans we have taken. This is Valashta Barrage. This is also on the Sabarmati river on the downstream side of Lakroda Barrage. So only two spans we have studied. So here this is, you can say, zoom copy of that 3D model. So here only two spans we are studying. So the scale is also half. Suppose there is scale is 1 in 100. So here 1 in 40 or 50 we are selecting. As the scale is smaller, then the result will be more precise. So here we are 30 means in 2D model we are trying to take the 30 to 40 scale. Same procedure which we are carrying out for 3D model, most of the procedure is same. So we are running this model for 10%, 20%, 50%, 75% and 100% design flood. First we are doing this, then observations, same observations, water level, velocity, scour, location and height of hydraulic jump. Here you can measure the height and location of hydraulic jump because we are studying only two spans here. Then adequacy of length of steeling basin. I have shown that picture, no? So that adequacy can also be studied. Then static pressure profile all along the structure. So that is also we are measuring. See here we are having pressure pipes. You can see this on the, that red figure is there. So on that pipes are there. So at various locations in this steeling basin, there are number of pipes are there. 1, 2, 3, 4, 5. 5 pipes are there. So at that location we are measuring the pressure in the structure. Why it is needed? You have already studied the hydraulics, no? So you can know whatever water is passing through any structure, there should never be creation of negative pressure. So always it should be positive, so that whatever water is falling, that is just attaching the body of the structure. There should be no any cavitation should be there. So for that we are measuring this pressure. See, this is our flume. This is our acrylic sheet from which we can see the on the from this observation chamber we can have the look of the water pattern. So we can have the what is the height of the jump, what is the pre-jump and post-jump, where it is starting and where it is completing, that you can study. See here you can see this white portion is there. So that end seal was previously it was on the border of the Stirling basin. But when we have run the model at that time, due to that end seal, there was creation of secondary jump, secondary hydraulic jump was created. So immediately all the project officials were also there, design officials were also there, and Gary people were also there. So they have decided that we have to, means it was needed to shift the end seal. So immediately the decision was taken and they have asked to shift it 6 meter away from the end. So this white portion is 6 meter away on the Stirling basin. This yellow are chute blocks are there, and then basin blocks are there. This is just to dissipate the energy. So this terminology you can come in during the your design, when we are learning the design of hydraulic structures in the water resources engineering. So this is the flume which we have constructed last year. So here I will explain the components, which are the components which are needed for model study. See, first in the starting, it is approach channel. So approach channel is means we are having this canal network. So from canal network, water is entering in the octagonal tank, from where water is means gated structure is there. So whatever model you want to run, that gate is we are opening. So from our octagonal tank, water is entering in the approach channel. Then we are having the upstream Stirling chamber. Upstream Stirling chamber, it is just to dissipate the means water flow. Then the most important thing is standing wave flume. In fluid mechanics, you might have studied various types of flume. So we are adopting standing wave flume. The standing wave flume is the measuring device which is from which we are giving the discharge. So suppose you want 10%, want to give the 10% run the model on 10% discharge. So the standing wave flume is the measuring device, and on the just adjoining you can see the chamber is also there. This gauge chamber is there. So water is still there. So we are having the pointer gauge on this gauge chamber. So whatever discharge is there, so that in terms of depth, we are giving the data, and on that basis we are running the model. So the standing wave flume is for discharge measuring. So after water is passing through standing wave flume, another chamber is also there. So before entering the water in the model, you have to, it should be very still water, it should be there, otherwise the natural condition you cannot attain. So again one chamber, downstream Stirling chamber we are constructing. So after downstream Stirling chamber, this is two-dimensional model. So there are two flumes are there on both the sides. So when you want to run on at present, we are running the right side flume. So on left side you can see that small wall is there. So that is obstructing the water to enter in the left side flume. So we are doing the work on the right side flume. So water is entering in the downstream chamber and then it is entering in the flume. So this flume is nearly 15 to 20 meter of length. And after at the end of the flume, we are having the end channel. So tail channel you can say. So water is whatever model is means run, that water is entering in the tail channel, and this is circulating system is there. So all this water is again going in the tank, and again it is recirculated, so that there is no any wastage of water. Now we will see the limitation of physical model study. See, this is the IS code 1400 1955 2001. So as per this IS guidelines for hydraulic model studies of barrage and weirs, clause number 7.3, model studies only help in finalization of structure. They have their own limitations, like difficulties in the reproduction of silt content of water, etc. Hence, for some of these studies, the result would give only qualitative idea. Therefore, the designer needs to incorporate the recommendations of the model studies only after careful consideration. What it show? See, whatever actual river condition is there, so we are reproducing here. So suppose sand is there, so sand cannot be converted in the scale, so very silt particle will be there. Suppose we are going to do that thing, the silt will wash away, so you cannot run the model. So there are some limitations, so we have to keep all these limitations also in mind, that some limitations are there, so you cannot exactly incorporate this result to the actual site condition. So these are the limitations. Some limitations are there that should keep in mind for final decision. And the actual water level, velocity and scour pattern may vary on the site as per actual topographical condition at the time of execution of work. Sometimes what is happening, suppose if we talk about Sardar Sarovar, so it took 56 years. So at every flood, the river bed is washing. So the river morphology is changing. So in that condition, whatever study was done earlier, even at the time of implementation, it may change. So directly that result cannot get on the site. So these are the limitations of physical model study. Now I will show some pictures of projects which have studied in the campus. So this is Ukai Dam. No, sorry, this is Sardar Sarovar Dam first. Sardar Sarovar Dam. This model is prepared with the scale 1 in 150. So the purpose of service spillway at different stages of construction. These are the service spillway. Sardar Sarovar Dam, there are 30 gates. So out of these 30 gates, 23 gates are in this portion. These are 23 gates, and these are auxiliary gates. So these 7 gates are operated when if it is needed. Otherwise, these gates are first operated. This is performance of auxiliary spillway which is studied. This is Garudeshwar Weir. This is just near Kevadia. So this function of these sluice gates in non-overflowing condition of Garudeshwar Weir was studied. These are the sluice gates which were did earlier for this operation. Then dry condition of Garudeshwar composite model. Composite surrounding structure, suppose upstream one bridge is there, that is also studied. Banks are also studied. So that is composite structure. So that is 3D also, you can say. So this is 3D structure of Garudeshwar Weir, and this is 2-dimensional structure, where only some portion of the structure. Here see, the length of structure is this much. So out of this, only some part, these 2 parts are studied over here. Again, this is the running of this model Garudeshwar Weir. See, these are acrylic, through acrylic sheet you can see the flow pattern. This model was run for 22.18 lakhs cubic discharge. So here this is the discharge. So in 3D you can convert this discharge into model discharge and then run the model. But in 2D, what you have to do is only two spans are there. So suppose whatever discharge is there, so suppose 20 spans are there, so discharge is for 20 spans. So what is the discharge for 2 spans? That you have to calculate, and that much discharge you have to pass in this 2D flume. Is it clear? So whatever discharge is there, we have to convert it into whatever portion we have selected. So in that much portion, how much discharge is passing. So that discharge we have to fix up on the standing wave flume, and through that standing wave flume, we are passing that much flood. This is 100% flood for Garudeshwar Weir. This is Ukai model run at 2 lakh cubic discharge. See, this is the Ukai dam. On the downstream side, this is natural. This bund is natural one. So in 2017, the study came. This is the photograph of earlier study, but 2 years back also, 2-3 years back also, we have studied this Ukai dam for the purpose because this bank was totally eroded due to this. See here, the meandering is there. So whatever water is coming through these gates, so due to this turning, the velocity is very high. So it is eroding this bed. This natural bed is totally eroded. So for that, they have suggested the protection work. So earlier protection work that was tested. See here earlier protection work is also there. I will show. This was the protection work. This is gabions. So that were earlier suggested. But what happened? These gabions were also washed out due to this high flood. So again they have revised the design, and here this whole was just lining work was done with concrete. At present, just 2 years back we have studied, so that was suggested, and finally they have gone for the lining work over this bank. So gabions were filled. See, this is the model run at 9 lakh cubic discharge with operating power channel. See, power channel is on that side. So water is coming, means whatever after hydraulic means there is, this is turbine, and up from there water is coming through this channel. So when it is operated, both the sides, these spillways are all operated, then power channel is operated, and what is the effect? Water is coming through this also, from turbines also, and from this also. So at 9 lakh cubic discharge with this operating channel, what will be the effect on these banks? So that is studied. This is the study of Chambal Riverfront project. This we have completed just 3 months back. Here also in Kota city, they have done 2 to 3 kilometers of riverfront. So that study came here, Kota, Rajasthan. So this is the barrage. Here also the same situation, whatever is there, that is prepared on the model. See here, in model was run, and we have, this is the fastest study we have completed. Within 2 months we have completed this study and submitted the report. See the model. So much. See, this is the riverfront. I have shown you in the previous picture. I have shown the structure, and this is the downstream of the structure. This portion is there. See, that is the structure, and we have constructed this rigid model because there is rocky strata. So first we have run the model without this riverfront, and that result were tested with the actual water level, and the validation was done. And after that again we have constructed this riverfront. You can see this riverfront, this zigzag pattern pala is there. So this is the riverfront on both the sides, so the channelized flow is there.
Discharge 7.2 lakh cubic.
See, this model is running at 7.2 lakh cubic discharge. Here also one any cut is there, because whenever any this riverfront is suggested, we need, means it is just majority in cities they are suggesting the riverfront. So for that we need some particular pool of water all over the year period. So for that one any cut is proposed here, so that you can get a water pool throughout the year. So that any cut is tested, and on the downstream of any cut, just nearby there are 3 bridges are there. So 2 bridges, overflow bridges, and one is low level causeway. So all that bridges
We have
also we have.
left 5 more minutes.
Yeah,
We have left it, so
yeah,
okay. Sorry to
yeah,
interrupt.
yeah. No, it's okay. It's the ending session, ma'am. So this is the model of riverfront. Presently, we are working on, means I have already mentioned that City Gandhinagar. So that is between Shahpur Bridge and PDPU Bridge. That is 4.5 kilometer riverfront is there. So that is mobile bed. This is rigid bed because Sabarmati is sandy strata, having sandy strata. So that is mobile bed model. And this is rigid bed model. So in rigid bed model, you cannot get a scour. This just for introduction I am giving. See, at present we are having one research scheme, purpose driven study under National Hydrologic Project. This is, means suppose any one of you are interested in research in masters or in PhD, this is very interesting subject and useful subject. So piano key weir. Piano key weir means what? Whatever existing weir is there. Weir means overflowing structure. There is no any gates. So on existing weir, if you want to increase the discharging capacity of that particular weir, see you can see this blue one. So the blue one is ground bar weir. This is at Brahmani 1 near Morbi. This structure we have, means this irrigation project we have selected is Brahmani 1 weir on Morbi. So we have designed, means this project is for just to increase the discharging capacity as well as storage capacity also, without increasing the submergence. See, you are having this much length only for this structure. Once you are suggesting the piano key, so the length will be increased. See, how much length? 3 to 4 times length will be increased. But what will happen? At the same time, due to increase of path of water, the head is decreasing. By fixing the piano key, we are decreasing the head. So the saving of head is our plus point. So whatever saving of head is there, so you can increase that much height of piano key without increasing the submergence on the upstream side. Because you are knowing if submergence is increased, then what will happen? Land acquisition problem is there. So that is very crucial. So to avoid that, in existing weirs, if you want to modification is needed to increase the discharging as well as storage capacity, because day by day siltation is there. Once you are constructing any structure, what is there on the upstream side during flood, there are number of debris and silt content is there, which is settling in the reservoir. So the capacity of reservoir is also very reducing day by day. So to increase that capacity, this is the best solution. This technique is firstly tried in the country France in 2006-7, and in India, in Andhra Pradesh, one piano key is constructed recently. So this project is taken for this study. So we are doing means we are running the model with this various alternates of piano key. This is inlet key, this is upstream side, this is downstream side. So this is inlet key and this is outlet key. So we are trying various alternates for this upstream this inlet and outlet key. Sorry. And we have studied 6 alternates. In first alternate, this number of keys here only means 1, 2, 3 and 4 means 4 keys are there. Then 6 keys and 8 keys. So that size is reducing. So that 3 keys first we have studied. Then inlet and outlet key ratio. This ratio 1.15, 1.30 and 1.45. That is studied. So this out of these 6 alternate, which is the best? So combination of these 2 in the 7th alternate we have studied. So for first project we have completed the study. Thank you very much. So here I am ending my session.
Thank you very much, madam. Thank you very much. That was very interesting that you gave
Samarth.
very brief idea about this particular condition of hydrological studies with the designs, that means giving proper examples that how you have studied it based on the 3D and 2D models, and how you have captured that pilot studies. Based on that, that was very much interesting for us to know about that hydrological study data, that what kind of data are required and how we can do it. Shilpa madam has to go into a meeting. So on behalf of her, I, Chintan Shroff, working as assistant professor in civil engineering department EIT, I am very thankful to you that you provided your time for this session, interesting session for us, and that will be very helpful for students in case of research studies, those who are interested for such kind of topics. Thank you very much.
Thank you, sir.
Thank you, ma'am. We are closing it down. Shilpa ma'am will contact with you.
No, thank you, sir.
Okay.
And thanks for giving me this opportunity.
Very much. Always, ma'am. Thank you. Yes, ma'am. We can leave.